the outlook and PyDB's roadmap. So here on this slide, you see the reasoning behind our next major step for PyPAHdb, and that is to make available computed path spectra that take the effects of anharmonicity into account. The figures on this slide clearly demonstrate the need for anharmonic spectra, as they provide the only means to accurately reproduce the path signature between 3 to 6 micron. This includes the 3.3 micron band, as well as emission between 5 and 6 micron that is totally absent in the harmonic computations. So this looks very familiar, I think. However, we now have an anharmonic radio button. So the progress that has been made, we can click Browse here. It shows that we now have an anharmonic library that currently holds 11 path spectra. The interaction is very much the same as demonstrated earlier. One interesting feature, though, is now in the transitions, where we can disentangle. We need to load the large file again, where we can now disentangle the fundamental vibrations contributing to the individual modes. So let's pick here one. Then a second table shows up where the different modes and their percentage and contribution are given, and by clicking each of these modes, then its associated vibration is shown. We can stop it, and yeah, we can play with it. A second interesting feature is now that we can now compare the laboratory measured harmonic theory and anharmonic theory, which is down here, this box, and the other version was already there. So yeah, that's used. It shows you just how nice anharmonic theory is doing. So what is next? Concerning the PAHdb website, we will be adding version 1 of the library of anharmonic computed path spectra, which you just saw. Version 4 of the library of harmonic computed spectra will be published, and version 1 of the library of gas phase laboratory measured path spectra will be added. Currently, the online fitting tool is limited to using only 256 paths because of resource constraints. To help with that, we intend to provide a selection of smaller predefined pools of astronomical paths. As for the Python suite, work is still needed to port remaining IDL functionality, like Alexander has mentioned, for instance, with the full width have max. We also intend to better optimize our Python code and be more Python-esque. We are also considering a GUI. Concerning PyPAHdb, the pre-computed matrix needs to be updated to use version 4 of the library of computed spectra. Admittedly, the results you saw earlier in the PyPAHdb update makes already use of this version. So if you rerun that, you might not quite get the same results. Here we would also like to provide pre-computed matrices at different excitation energies. Similar to for the website, we are also intending to provide optimized reduced site matrices with pools of astronomical paths. These are just a few things on the roadmap, and we are excited to see where it will all lead.